Hi, in this tutorial I'm going to show you how to easily create a creature locomotion in Unreal Engine and Maya. Overall, locomotion system can be quite a challenging task, so it can be an issue even for experienced animators. But essentially, under the hood, any locomotion system is just a bunch of different animations. In this tutorial, we'll go in details through every part of a state machine and discuss unobvious moments. We're gonna review turn and spot animations, movement cycles made for different directions, also various transitions, like start animation is transition from idle to movement. Also we're gonna review directional starts, and stop animation is transition from movement back to the idle. Also we're gonna discuss extended movement, like walking on the walls. And in the end we're gonna assemble everything in game engine, so you'll have a working prototype of a creature locomotion, where you can see how all works in real time. The rig I'm using in the tutorial is free, and it will be available by the link in the description, as well as all animations. To speed up the animation process, I'm going to use a smart layer script, and along the way I will share several very helpful and interesting techniques. So by default, when the creature is not moving, we play idle animation. Usually idle animation is just a short cycle where a creature does nothing, so I think here everything should be quite obvious. And a little bit more tricky part is turn and spot animations. So you see, when we press input for a short time, a special animation is played in this case, and in this animation creature makes a turn while staying on exact the same spot. So usually any locomotion requires several turn animations. So we can make animation to the 90 degrees, to the left or to the right. Also we can make turns 45 degrees and 135. So in order to assemble a full set of turns, we're gonna require 8 different animations made for different directions. So essentially, turn and spot animation is a short clip which starts with idle pose, then the creature makes several steps and turns to the required direction. So this animation I did manually. I spent a couple of hours to do this, and as you might have guessed, creating a full set of turn animations in all possible directions, it's quite a complex task and it can take a lot of time. But actually we can use a little hack with animation layers to transform one turn animation to another animation with a different turn value. For example, here I have a layer which transforms this animation from a 90 degrees turn into the 45 degrees turn. And obviously there is no fit slicing and everything looks okay. Or maybe we can transform the animation into the 135 degrees turn, like this. Again, using a simple animation layer. And the animation looks organic, like it was animated like this from the start. Of course there can be minor inaccuracies, but again there shouldn't be any problem to fix them manually later. And we can easily go further. We are not limited by rotating the character only in one plane. We can rotate it, for example, upwards. If let's say the creature is able to walk on the walls, or maybe rotate it down. If it's crawling on some surface. So let's quickly see how this technique works. I'm gonna delete these animation layers to have the original animation. And if let's say we want to transform this 90 degrees turn into 45 degrees, all I have to do is just select IK controls. I have them here in the selection set, maybe pelvis, maybe the main control. So I will add them to the animation layer, set a key in the beginning of the time range and in the end, and just rotate my character to have the required turn value, for example 45 degrees. So everything will be sliding, and after that all we have to do is run the script in the transformation mode. So I'm gonna choose option transformation. Maybe we can specify the pivot object as this spline control. It should work great as a transformation point because it's close to the center of mass. Okay, specify the center. We can also change the layer mode to the override and enable the run simulation checkbox because we bake a lot of controls and it will make it a little bit faster. Now we select the layer and run the script. And we got a 45 degrees turn animation, obviously without any fit sliding. If we want to make, let's say, 135 degrees turn, everything is the same. We just specify the required value. Okay, so everything will be sliding. Now we select the layer and run the script. And we got 135 degrees turn. without any feed sliding, and everything looks quite legit, like it was animated like this from the start. If you want to make, let's say, a 180 degrees turn, it might be a little bit problematic. Let's see what I mean. Let's put 180 degrees. We will have even bigger sliding, and try to run the script on this layer and see what happens. So again, the script worked. We have our character turning 180 degrees, but I would say in this case the animation has issues. The turn is simply too intense and the steps are kind of too large. So in some point of animation, legs are going through each other. Maybe it can be fixed manually, but I would say in case of such significant adjustment, the result might be not so great, so it might be better to create this animation manually, maybe make it longer, maybe not 45 frames, but actually 60 frames or even more, and maybe add some extra steps to your animation. But with the minor adjustments, like you saw, everything works quite well. And like I said, we are not limited by rotating the character only in one plane. We can do it in multiple planes. For example, here I have two prearranged locators to rotate the character up, so I can match the main control with these locators. The animation will look like this, like the creature is walking on some wall. Now, after I run the script, the sliding is gone, and we got a quite interesting result. And in similar way, we can rotate the main control 90 degrees down. Again, I will use this prearranged locator, just match translations. Everything will be sliding. Now I select the layer and run the script, and sliding is gone. And the creature behaves like it's crawling down on some surface, I don't know. And also, I forgot to mention, when we work on any animation with turns, the animation of the root is very important. So overall, animation of the root depends on many factors. Would it be a code-based locomotion or root motion based? In our case, we're gonna use root motion. And when we do a turn animation with root motion, it's very important to not rotate the root bone in the beginning and the end of the animation to avoid potential issues with blending. So here, if I make a snapshot of this root bone, it will look like this. So in the beginning of the animation, we do not apply any rotation to the root bone. Then we rotate root joint 90 degrees, same as the turn animation, and then again we do not apply any rotation. So if you make root animation, let's say like this, the blend in engine will destroy a little bit of this rotation in the beginning of the animation, and also a little bit of the rotation in the end. So the result rotation in engine will be something closer to this curve, and we will lose a little bit of turn value. So again, just keep the root bone rotation static in the beginning and end of the animation, and in engine everything should work fine. And to better understand the transformation algorithm, I would like to show you a few more examples. For example, if we have a jump animation like this, like some jump attack forward, we can easily transform it to jump to another direction. For example, jump to the right, and all the turn can happen without the feet sliding. Or we can also transform it to jump to the left direction. Again, all the turn happens without any feet sliding. And we can also add some movement on a different plane. For example, if you want the creature jump on some platform, we can easily do it with the animation layers. So again, this is all one animation transformed with animation layers, and all of these adjustments can be easily done with the transformation algorithm. So let's quickly see how this technique works. I'm gonna delete all these animation layers. So initial animation looks like this. The creature makes some preparation, then it jumps. And as usual, to make it work, we would have to add IK controls and main to the animation layer. Set necessary keys. So here I would set key at the frame 0, then maybe at the frame 25, then maybe at the frame somewhere around here, and also in the end of the animation. After that, all I have to do is just relocate the main control. I can just rotate the character to the required direction, then simply move the main control. We can also set the keys on the main control linear to make things a little bit easier. So the animation looks like this. Everything is sliding. The character turns and jumps into the required direction. After that, I would need to just select the layer, choose the algorithm transformation, maybe specify the pivot point as this middle spine object, maybe change the layer to the override and enable simulation, and then just run the script. And as a result, we will get animation of turn, which would happen without any feet sliding, and then the character will be jumping in the required direction. And if you want to tweak the result, it's super easy to do. Again, you can just go to this original animation layer, make any adjustments in the keys, maybe for example to move the character further in this direction, to make the jump a bit longer, then simply run the script again. So in order to make the transformation precisely, maybe we can create some guidelines. For example, we can create a snapshot object from the main control. Then we can group the snapshot and rotate the group into the required direction. For example, minus 90 degrees to make the jump to the right. And then in this animation layer, again, we can just simply match transformation with this locator. Again, do it at the frame 25, then at the frame 48, and also in the end of the animation. So again, the script doesn't care that the character is sliding between the keyframes. All the script cares is the position and rotation of the character in the frames where we set keys, so we can safely manipulate the character and everything should work okay. So at this point, I can simply select the animation layer and run the script in the transformation mode. And as a result, I will get the animation where the character turns 90 degrees to the right, and this turn happens organically without any feet sliding. And if you want to make the character jump on some platform, it can be easily done as well. Okay, I'm gonna reset these keys. Then adjust the main control in these keyframes, maybe add a little bit of extra rotation. By the frame 48, I'm gonna match the main with this platform. Just simply match translation, match rotation, adjust the orientation, and maybe add a little bit of extra rotation by the end of the animation. So adjustment in layer looks like this. The creature is jumping on this platform, then rotates a little bit, and everything is sliding. But after we run the script in the transformation mode, the sliding should be gone. And we got the creature jumping to this platform, and we also added some rotation to the animation, so you can use this technique to adjust animations very quickly and easy using simple animation layers. Just rotate the character, relocate it, put it in the exact spot you need, then run the script in the transformation mode, and it will do all the magic. The next thing I want to talk about when we start animations. So here I created a movement cycle of this creature, and if you would like to put this animation in engine, we would need a special transition animations from idle to this movement cycle. So in engine it works like this. When I press the input forward, I got a start animation, which allows to seamlessly blend into the movement cycle. So again, when we press the movement input, the start happens without any feet sliding, and then we have a seamless transition to the movement cycle. So in other thing, I have few start animations already. This is a start forward animation, which is essentially a transition from the idle to this movement cycle. Also, we need directional starts. For example, if the character starts not in forward direction, but maybe to the left, a special animation will be played in this case. And similar to other directions, let's say 45 degrees, or 135 degrees, or maybe even 180 degrees. And similar to turn animations, we can also make transitions upwards. For example, like this, if the creature is starting movement on the wall, or maybe like this, if the creature goes in the direction down. And all of these animations can be easily done using a simple Volok cycle and animation layers. So traditionally, to make the start animation, we can simply blend the idle and the movement cycle. It can be done through the time editor or animation layers. So here I have a simple idle animation, and we can select all controls, add them to the animation layer, set one key, change the layer mode to the override, and set, let's say, 0 key. Then I can go to the studio library and apply a walk cycle on this layer. And I will get character moving. After that, all I have to do is just to play with the layer opacity. So for example, in the frame 0, we will have opacity 0. And then slowly, let's say with the frame 20, we will increase the layer weight to 1. And in that way, we will get a smooth transition between idle and the movement cycle. So here it might be a little bit tricky because the position of the main control changes and you will have to manually fix the sliding on these legs. So I would like to show you a little bit different approach, which might be easier and faster. For that I will delete this animation layer, delete the idle animation, simply go to the graph editor and delete, and again apply the movement cycle, but now do it on the base animation layer. So okay, we have a movement cycle, and at first our goal will be to, let's say, soften this movement of the main control, because it starts with a constant speed value. So ideally we would like to make the transition, let's say, smooth, something like this. But we cannot do this directly, because if we soften this curve, we will get the feet sliding. And a solution to this could be bake this animation to the curve and then work with this curve to adjust this animation without the feet sliding. So if you saw the tutorial about the spline adjustment, you already know how it's done. If not, I will put the link with the time code in the description. So basically there are scripts which can generate a curve from a path of the object, like this. So the script baked me the movement of the main control to some curve. And there is another script which allows us to switch space in the animated motion path on this curve. So I will select the I key controls and also main, select the curve and switch space into the animated motion path on this curve. So we see some system was created in the scene, and now if we manipulate this curve, we will also change animation of the creature, and this change will work without the feet sliding. So here we don't need such significant change. All we have to do is basically soften the beginning of the animation. So let's take a look at this animation. So I think maybe by the frame something about 20, it should reach its full speed. So we can select the first vertex of this curve, and using the soft selection, we can regulate the affected area. So I can select vertices like this, then maybe simply scale it down and move it to be somewhere here. So as a result, the creature will start its movement slowly and then smoothly interpolate into the movement cycle. Well, here you can play with the curve. Maybe you will not get the perfect result from the first time. I think this looks okay. We have minor issues with the leg, but we can fix it later. So after I'm satisfied with the curve shape, I can maybe reset its position to be in the middle of the scene. Then I would need to bake I keys and main and delete all extra systems from the scene. Simply bake and delete this curve as well as the motion path locators. Okay, so animation looks like this. And after that we need to make sure that the first pose is idle. For that I will select all rig, add it to the animation layer, set one key, go to the studio library and apply idle pose, and set key of course. So the first pose is idle, and then somewhere about let's say frame 20, we can set a key with 0 value. So our animation will look like this, everything is sliding. But it's not a problem for us, because we have the adjustment blending. Again, we don't necessarily need to apply the adjustment blending on all character. We can do it just on the I key controls. So I will select the I keys, maybe extract them from this animation layer, code I keys, and simply run the script using the offset algorithm. Okay, so the sliding is gone. You can notice that the body of the creature starts moving really intense, and ideally we need to soften this movement in the beginning of the animation. So I will select these body controls, add them to another animation layer, change this layer mode to the override, set 0 key, again apply either pose or animation from a studio library on this override layer, call it, let's say, idle body, and then simply animate the opacity from 1 to 0. And if you have any issues with rotation variation, you can change the layer mode rotation accumulation from by component to by layer. Okay, let's maybe play a little bit with the weight curve. So this result should be acceptable. Also, we can tweak the movement of the main control, because here the translation curve maybe not exactly what we want. For that I would need to bake IG controls to the world space. And now I can manipulate the main control without affecting the feet. So I can simply go to the curves of the main control and adjust them exactly as I need. Maybe play with interpolation, maybe apply some smoothing. So this already looks like a decent start forward animation. I would say we have minor issues with the legs. If we select one of the locators and create the motion trail, the issues will be clearly visible. So maybe we can smooth these keys a little bit. Maybe this locator as well. Again, it has a little bit of weird movement. So okay, I spent a little bit of time. I think it's fine at this point. So after that I can just select everything, just bake everything, delete all layers, and delete all locators. And we have a start forward animation, which we can later use to create directional starts or starts on the wall. And it was done very quickly and easy, basically in a few minutes. So in this tutorial we discussed how to apply adjustment with torrents to easily create turn and spot animations. Also now you know how to easily create start animation. In the next episode we're gonna create directional starts. So thank you very much for watching and hope to see you next time.